How's it going, folks? We are going to go over kind of a brief overview for 2D vectors. This is not really like physics. I mean, if you've taken physics, this will help a little bit since you'll have some basic understanding of how vectors work. But the way we do vectors in math is not really the same way they do it in physics per se. Although there's some overlap, obviously. But anyway, just try to follow along with this as the best we can do. I'm just going to give you a brief overview of what vectors are. And I suggest you watch this video before you start doing the guided practice. It's not necessary, but it might be helpful. So I'm going to just write this here into 2D vectors, and we're just going to talk about them for a second. And I'm going to try to do a crash course here. And we're going to try to get done with all the vector unit this week. Okay, so 2D vectors. So if I have a vector has two things. It has a magnitude and direction. Okay, if you've ever seen Despicable Me, that's exactly true. Vectors have magnitude and direction. Okay, so if I have a vector, we write vectors in a couple of different ways, but let's talk about that for a sec. If I have a vector in IB, let's say we have vector u. Okay, so the vector u, and actually let's just not put that there. Let's put it underneath here. So we have vector u. And this could be written as a matrix, okay? So when I say as a matrix, we can write it, we'll just make this up, 3 and 4, okay? So what this means to me is that I have an x component right here and a y component right here. So these themselves are vectors. So we have 3 going in the positive x direction, right, from some sort of reference point. And then from there, we're going to add to it another vector going 4 in the y direction. So you can kind of think of this as being x and y, okay, when I write a vector like this. So the actual vector u will start where this whole thing started and end where it all ended, and we call this vector u. So we call these components of the vector. This is an x component and a y component for a two-dimensional vector, and the vector u is this right here. Okay, so when I write a vector like this, 3, 4, it means it's going to go 3 this way, 4 up, and this is the resultant vector. We're adding these two vectors together. So when you add vectors together, you add them tip to tail. I'm adding this vector here to this vector here, and this is the resultant vector. That's how that works, okay? Another way you could write this is you could write this as 3i plus 4j. So when I say that, I is itself a vector. The vector I is going to be 1, 0, and the vector j is going to be 0, 1. So what this means is if I have a coordinate axis here and a coordinate axis here, the vector I is going 1 in the x direction, and the vector j is going 1 in the y direction. So when I say 3i, what I'm actually doing is I'm taking that, when I say 3i up here, I'm taking this vector here, and I'm multiplying it, this vector right here, I'm multiplying it by 3, which means it's going to be 3 times as long, so it's going to be a 3. So that's what this means, okay? When I say 3i, it's just going in the positive x direction, a distance of 3, a magnitude of 3, okay? So we'll talk about that. So you can write this, when I say this or this, these are the same thing. It's two different ways of writing the same vector, and that's going to be important, okay? So we're just adding, we're adding the two vectors together. That's literally what we're doing. We're adding this vector plus this vector to get that. So this is really a vector addition, okay? Addition of two vector components. We call these components when we're talking about x and y, and this gives you the resultant vector. That's really important. You should understand that. It's really not that complicated, but it can be confusing for some people, okay? The next thing I want to talk about, very basic, is what's the length of this vector u, okay? So when we say length of a vector, we call it a magnitude. So a magnitude, one of the components of making a vector is finding its length. That's what happens here. Magnitude. Okay, I don't know why it's doing that. Let's see if I can get rid of that. I don't know. Okay, let's get it off of there. So the magnitude. So the magnitude right here. Let's talk about magnitude. when we say magnitude of u, we put it in an absolute value form right here. So whenever you see this little absolute value mess, they're asking for the length of the vector, the magnitude. So think about this vector u as being a right triangle, because it is. Okay, this is always going to be true when you're finding magnitudes. So what I have here is this squared plus this squared is u squared, in other words, right? So what this means is to find the length of u, we're just going to use the Pythagorean theorem. If I say 3 squared plus 4 squared is u squared, that means that the magnitude of u will equal the square root of 3 squared plus 4 squared. This is how we always find it. We just square the two vector components, x and y, add them together, and then take the square root. It's always like that. Okay, it's really just using the Pythagorean theorem. So in this case, what I have here is this is going to be 9 plus 16. 9 plus 16, which is root 25, which will be 5. And as you can see, this magnitude here will be 5 because what? Because this is a 3, 4, 5 Pythagorean triple. We already knew that anyway, right? But that's how that works, okay? So the magnitude of that vector, that's how you find a magnitude, okay? So that's a magnitude of a vector. Whenever you see the symbol, it means magnitude. Okay, so a couple other things we need to talk about. If we're talking about direction of a vector, which is very uncommon actually in IB, it's more common in physics. We don't usually find the direction of the vector per se. They're usually more interested in finding angles between vectors, but not the direction of vectors. But let's just say off chance that you get a question like that. This angle right here represents the direction of the vector. So if we call this angle theta, okay, how do I find that? Well, this is pretty straightforward. So let's just talk about direction really quick, just for the sake of argument. The direction is really easy for this case. So the components create basically an opposite and adjacent sides. This is a tangent, basically, is what you're looking at. It's a slope, as it turns out, right? It's rise over run, if you want to think of this being a line. This is true. That's going to come into play later on when we talk about vector equations of lines. But what I'm going to say here is that the tangent of theta is going to be 4/3, 4 over 3, y over x. So theta itself, very simply, will be the tangent inverse of 4/3. Right? And if I access the calculator and I'll say, just create a new document here, and I'll just say, okay, I'm already in degree mode, so I'll say, all right, I'll just do tangent inverse, of, let's see, 4/3. And that will give me 53.1 degrees. Okay, so this would be like 53.1 degrees. This is technically the direction of the vector. It's 53.1 degrees from the standard position. Okay, that's where the direction the vector is going in. Like I said, that's pretty uncommon. Magnitude is very important, but the direction, usually you won't see that in an IB sort of question for mathematics. But that's just how you find it, just in case you get one. I'm not saying it never happens, but it's rare, okay? But you should know how to do it. It's pretty straightforward. Okay, so we talked about that, magnitude, direction. We talked about what these vector components mean, I and j. So you can write vectors either this way or this way. It's the same thing, okay? So let's talk about adding vectors really quick, adding, subtracting vectors, and then I will talk about the dot product, the scalar product, and then that should be it for the 2D stuff, I think. Well, except for vector equations of line. We'll do that later. Okay, later this week. So let's talk about adding vectors. So you add and subtract vectors tip to tail, okay? So let's take the vector u again. I'm just going to make these up. 3, 4. And I'll have another vector called v, which I'll say is, I don't know, doesn't make any difference, 5 and 6 or something, okay. And then we're going to add these together. So what I'm going to do is I'm going to say, okay, the vector u, let's actually put this on no, let's just leave it like that. We're going to say, okay, this is going to go 3 this way in the x direction. This is x and this is y. And we're going to go up 4 in the y direction. Same thing as before. So this is called vector u right here, vector u. Okay, and then when I add v to it, what I'm trying to find here is I'm trying to say what is u plus v, and I put these little lines above it indicating that these represent vectors. I'm asking, what is this? Okay, so I have vector u. So let's, on the end of that, we add them tip to tail. Right on the end of u, I'm going to add a v. So v is going to go, in this case, 5 to the right and 6 up. And I have another vector I'm adding to it, and this is it. Let's do it in purple. This will be vector v. And then what's going to happen is I'm going to get a resultant vector from here to here, a resultant vector. And this resultant vector is going to be called u plus v. Okay? That's the resultant vector. Okay? So when I do this, this will be really easy. We're just going to say when you add these vectors together, we're going to have 3 and 4 plus 5 and 6. We're just going to add them together. So I say 3 plus 5 is 8, and 4 plus 6 is 10. So what's really happening is, let's do this here in a different color, like orange, I guess. So from here to here, this component here will be 8, and this component here all the way to the end of this will be 10. That's what I'm showing you. So this represents this vector right here, which we call u plus v. And that's how we do that. Okay, so you add them tip to tail. Easy stuff, quite frankly. Okay, now if you have a vector that you're subtracting, it gets a little different. So let's actually take u minus v in this case. Okay, so again I have u, which is going this way, and if you recall, v does this. Actually, let's change it up. Let's make it a little easier to understand, because these vectors are not great. I should have given you some different numbers because they're just too close together. So let me just change that up a little bit. Let's just redefine these. Let's call it a and b instead of u and v. We'll just make new ones. Okay, we'll keep a as 3, 4. And b will make it something else. We'll make this bigger. 8 and -2. Okay. So if I were to add those, I would have 3, 4 going this way again, and then on the end of that, I would go 8 this way and down 2. Okay. So let's actually add that. If I go 8 this way and down 2, I would get a vector that looks like this. So this vector would be a plus b. Okay, because this is going which way? This is going 3 this way, 4 up, and then this one's going to go what? 8 this way from the end, tip to tail, and this is going to go down 2. So what I actually have here is I have vector a right here, and I have vector b right here, and this is the resultant a plus b. So if I were to go through and say, what is a minus b? This is a little different. When I subtract b, I'm actually going to add the negative of b. The negative of b is going the opposite direction of b. It's the same length, same magnitude, it's just going the opposite direction. So what I have here is I have a, and then I have negative b. I'm adding it together. So you can write this as being a plus the negative of b, in other words. So this is a, the negative of b, you're adding them together, okay? And then your resultant vector in this case would be from where this starts and where this finishes. So this would be a minus b. And this is how you write these things. So your vector will be your resultant vector. It's a and then plus the negative of b. Since b is going this way, negative b will go the opposite way. And that's how you subtract vectors. Okay, so that's kind of when I say what is a minus b, it itself is a vector. This is a vector itself. It's just going in this direction, and you have to understand that, okay, for these questions. So the last thing I'll talk about here before I, make this more convoluted than it needs to be is the scalar product. Okay, so your scalar product, which is often referred to in America as a dot product, but we call it a scalar product in IB, and I'll tell you why. Okay, is when I'm going to make up two vectors again. Keep this the same, and then we'll have another one called v, and we'll just make these numbers up. This will be -3 and let's make it 6. Okay, so scalar product, very important. Scalar products here they're always equal to something. So when I say a scalar product, we're to say this dot this. This means scalar product. It's also called a dot product because this is literally a dot. Whenever you see this dot, it's a dot product, which is the same thing as a scalar product. So why is it called a scalar product? Well, because the answer for this will be a number, and a number is called a scalar. So what you get out of this product is a number, and because it's a number, which is the same thing as a scalar, they also call it a scalar product, okay? But we call it a dot product here in most other contexts. So if you look at a textbook, this will probably be called a dot product in the United States, but IB will call it a scalar product, so don't freak out. This is always equal to something, though. It's going to equal the magnitude of u, which is the length, which we already discussed, times the length of v, or the magnitude of v, and then this is going to be times the cosine of the angle in between the two vectors. So we actually use the scalar product to find angles in between vectors in 2D form here. So I'm going to do an example like this, and I'm going to show you some stuff here. So how do you find a scalar product? This part right here, the scalar product. This part is called the scalar product. To find the scalar product, we're going to do this. I'm going to say scalar product here, or dot product, is equal to, we're going to multiply the x components, this and this, the 3 and the -3 for both vectors. And then what we're going to do is we're going to add the product of the y components, which is 4 times 6. And this is it. That's all there is to it. So it's going to be -9 plus 24. Okay. And then what this is going to be is 15. All right. So what this means is that my scalar product is 15. That's really the answer for the scalar product. But this is telling me something about the angle in between the two vectors. And here's what this means. Okay, I'm going to write this in a different color. If your scalar product is positive, we'll call it greater than 0, the angle between the two vectors is acute, meaning it's less than 90 degrees. Okay. If your scalar product is equal to 0, it means that the angle is 90 degrees. So what this is very important here. If the scalar product, this ends up equaling 0 after you do this process, it means that the two vectors are orthogonal, which means perpendicular. It's another way of saying perpendicular. The angle between them is 90 degrees, so it makes a right angle in between them, so they're perpendicular to each other. Okay, or orthogonal is another word for that. So let's write that, orthogonal. They might say that, but it means perpendicular, just another fancy word. Okay, and then we got the scalar product. The last thing that could happen is it could be less than 0. That means it's negative. The angle in this case will be obtuse, which means it's greater than 90 but less than 180. And these are the flavors that you can encounter. So on this dot product I just encountered here, this is a positive number, greater than 0, which means the angle between these two vectors is acute. Okay, very important you understand that. So here's the dealio. Oops, this thing is jumping around here. I'm actually going to find that angle. Okay, so here's what I found. This scalar product is 15. I already know that. Now I have to find the magnitudes of these guys. Okay, so how do you find a magnitude of u? The magnitude of u, and you should be able to do this in your head after a while, is the square root of the components I have right here, guys. The components I have here added together. If you recall, we've already done this. This is going to be 3 squared plus 4 squared, and that's going to equal the square root of 9 plus 16, which is 25 again, and this is going to give me a 5, of course. And then the magnitude of v, we're going to have to find as well, the magnitude of v. This will be the square root of its components, this and this. This is going to be negative 3 squared plus 6 squared. That's going to give me 9 and 36, so this is going to be the square root of 45. Okay, so square root of 45, that's really not a complete square, so we're just going to leave it as root 45. And then this is what we're going to find. So we have this dot product here, so here's what we're going to get. We're going to say that 15 is going to equal 5 times root 45, and this is going to be the cosine of theta times the cosine of theta. So to find the angle between them, we just solve for cosine by dividing both sides by 5 root 45. So this is going to be 15 over 5 root 45. And that's what cosine will equal. And then the last step we'll use is we'll do the cosine inverse. The cosine inverse of that 15 over 5 root 45. And this will actually give me the angle. So then you have to get to the calculator and get that done. So let's do that. So I will say, let's see, trig, I want the cosine inverse. We're going to make a little fraction here. And this is going to be 15 over 5 root times root 45. Oops. And then there we go. That's going to be 63.4 degrees. So it's acute, as I said. So what's that? 63 is what I said? Yeah, 63.4. Yeah, 63.4 degrees. So that's how you find that, right? That's how you find that. Another thing to look out for is when two things are orthogonal. I'm going to tell you how to tell. Okay? If you think of, let's just make this up. So this is the way you can find it, right? And these rules are important, by the way. You should kind of commit that to memory. But for the orthogonal case, which is perpendicular, right? Orthogonal. We have the orthogonal case, we'll call it. We got two vectors. Let's just make them up again. Oops. Three, 4, and then here, let's see, you can think of this, here's how you can tell. Let me show you, just be very clear on this. If I have, this is my x and this is my y, you can think of this as being a slope. The slope would be y over x. You can say it's 4/3, okay? Now, if I want the opposite reciprocal of that, that would obviously be negative what? 3 over 4. So what I'm going to think is, if I have another vector where the y is negative 3 and the x is 4, so what you're really doing is this. You're switching the numbers, right? And then you're making one of them has to be negative. It doesn't matter which one, but one of them has to be flipped. The sign has to flip. But these two vectors will be orthogonal when you see this. So when you see these numbers flipped and one of them is made negative, and they can be scalar products of each other. What I mean is scalar multiples of each other. What I'm saying is you can multiply this by both of these numbers by like 2 and it would still be perpendicular to this one. It doesn't matter if you multiply it by a scalar. But let me show you what's going to happen here. When I do the dot product or the scalar product of this, this is going to be the x times the x, which is 3 times 4. And then plus y times y, which is 4 times negative 3. We're going to multiply the bottom ones, 4 times negative 3. And what I end up getting here is 12 plus negative 12, which of course is equal to what? 0. This means whenever you see the dot product, or scalar product as we call it, equals 0, these two vectors are perpendicular. When you draw these, you're going to have one that's going 3 in this direction, 4 up. Okay, that's your first one. This is called vector u, we'll call that one. And then I'm gonna add to the end of that 4 and negative 3. So if I go this way, 4 and down 3, I'll get another vector that's doing this, another vector here, and we call this vector v, And what I'm telling you, in no uncertain terms, is that the angle here between the two vectors is going to be 90 degrees. That's what I mean by that, okay? So hopefully that makes sense to you, all right? And that's what it means to be orthogonal. They're just perpendicular. It's all it means. Anyway, that's all we're going to talk about for the 2D stuff, and then we'll get to the vector equation.